So, antimatter. It's very similar to normal matter. There are antiprotons, antineutrons, and obviously anti-positrons. They are identical to protons, neutrons, and electrons, but they have the opposite charge. Protons are positive and antiprotons are negative. Electrons are negative and positrons are positive. Neutrons have no electrical charge and neither do antineutrons. This is because they're both made out of quarks, and those ones are charged. Neutrons are basically neutral, so the quarks and antiquarks annihilate each other and not the protons and antiprotons. Electrons and positrons are just their own thing. And I know that they are more elementary particles, but I won't talk about them. At least not today. And yep, all of them do have their own antiparticle. So alright, what happens when matter touches antimatter? They turn into gamma rays. So that's why all the antimatter in existence is stored in a vacuum and with magnets so that it doesn't touch anything. Oh, this is the most efficient energy conversion in the universe, by the way. It takes around 10 grams of matter and antimatter to get enough fuel to get a rocket to Mars. Granted, 50% does turn into neutrinos, so it would take like 20 grams of each. So, where can I find antimatter? I don't know. And neither does the scientific community, but there are 3 theories. The first one, there's around the same amount of matter and antimatter in the universe, but they are very, 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 very far away one from the other. Which would make things like antiplanets and antistars possible, and we couldn't really tell them apart until we sent a rover that explodes with the energy of a thermonuclear weapon. While we're on this, matter and antimatter reflect light on the same way, so an anti-Earth wouldn't look like this, it would look like this. This is our Earth for reference. The second one, matter and antimatter, may not be exactly the same and antimatter just decays more than regular matter. And the third one, there was just a bit more matter than antimatter after the Big Bang. You know, just a bit. When antimatter is studied, it isn't just found somewhere out there. It's generally made in a lab. How? Inside a particle accelerator, some protons are accelerated until they crash into a wall of iridium, and the energy from that generates matter and antimatter. And they are then separated with magnets. Also, bananas produce positrons. No, that's not a joke. And this lets us make anti-atoms. All of our research has unveiled that they're just like regular atoms, but with their electric charge multiplied by -1. And as antimatter is so hard to make and store, a single gram costs $625. Hold on, those are zeros. A single gram of antimatter costs $62.5 billion. It's the most expensive substance on Earth, and it could perfectly be just dirt! So, what could I do with antimatter? What did I just say? Become a millionaire! Do you know what I would give for all of that money? Do you know what I would make a banana out of antimatter and just throw it out the window? The second that thing has contact with air, you'll have an explosion very similar to the one in Hiroshima.